projected, a massive transmission line, addition of massive transmission lines in coming years, and substation capacity additions also in the wake of more and more capacity build-up for the power. So how we are going to prepare for it, and what will be the role of the state utilities also in this scenario?
Okay. So let me put it in this way. See, the amount of RE that is going to be integrated is enormous, right? So 500 gigawatt of extra power which is getting injected into the system will be not only intermittent in nature but also erratic in nature, supported by ESS, long energy battery storage systems, long duration battery energy systems. So the integration of those things, amalgamation of resources in addition to the storage systems, this will call upon high power transmission evacuation requirements. Plus, over and above, there is also an emphasis of production of green ammonia and green hydrogen, because hydrogen is the future. And incidentally, Odisha is going to be one of the major hubs for production of green hydrogen and green ammonia in two port-based cities, that is Paradip and Gopalpur. Kerala is occupying one, and I think Maharashtra is also having one. There are three identified corridors, and they will be requiring large amount of power for there, because the entire input power to production of green hydrogen has to be green. So we need to have green energy transmission corridors. Already at 750 kV level, we have got a 800-kilometer long transmission network being tendered out, so that it will be only evacuating the green energy corridors. So yes, we have the requirement of long distance transmission line corridors at extremely high voltage, 400 kV and above, 750 kVm. As I was mentioning, only the tender is out, and the construction will start very soon. And everywhere in Pan India today, if a developer applies for a evacuation arrangement, they have to wait, because the existing infrastructure is not adequate to have any additional capacity. I think I've answered your question fairly.
Got your point, sir. Thank you.
Present scenario in 2020-25, we have total capacity of 500 gigawatt. Okay, and if you look at the data of CA, that is projecting 900 gigawatt by 2030. That addition of 400 gigawatts call for additions of inter-regional transfer capabilities, and presently that is 120 gigawatt, and that is to be enhanced by 150 gigawatts in next 4 to 5 years. When you talk about inter-regional transfer capability, you have to look at the transmission system. You have to look at the 765 kV transmission system, 100 kV transmission system. And if you look at the latest report, there is another issues with RE integration, curtailment of solar power. I was going through one report. Many megawatts were curtailed in Rajasthan itself because of evacuation problem, intermittency, and the peak demand issues of my system. We have to also look at the solutions like energy storage systems, so that we can easily meet our peak. We can store the power generated by RE. We can use when and when required, and we can evacuate into my systems suitably without unnecessary losses in my systems. We have to work in transmission line, energy storage system, pump storage systems. We have to work for the solutions of coordinations of protection systems. We have to work for the sustainability systems. We have to make our regulations and policies, and we have to implement all these with determination, so that the targets and projected assumption can be achieved without any hurdles, curtailment, or failure or power cut in India. When you talk about expansion of power systems, at the same time it calls for the safety requirement. You can't do anything, you can't go for the development by ignoring the safety.
Per se, it's a very vast subject. CA has formulated certain guidelines, but we are yet to reach to that level. There are a lot of deliberations going on at the state utility level. How do you do it? Like demand side management, like smart grid systems. There are a lot of things which are being discussed and contemplated upon. At the same time, we are far behind to get anywhere nearer to asset monetization of the entire infrastructure, entire transmission network, power evacuation equipments. See, power evacuation primarily is comprising starting from 415 volt transformer to 400 kV transformers or 865 transformers, SBDC systems, all gamut of switch gears, transmission network. There's a very large network of power evacuation equipments available. And asset monetization is a very gigantic task. It has been in the talking stage, in the debate stage for quite some time now. It's not a new concept as of now. CA has given the directions, and so on and so forth. It has not been seen the ground of the day. It has not seen the light of the day, I would say. So it is going on for some time in a very small scale, pilot scale. People have tried to do something in our state also. In certain pockets, it has already been done with the help of some companies, outsiders. But in the reality, it is a long way to go. I would say that. Here, the prime a goal is how do you integrate the RE power? Given the mandate by the government of India, by the government, the state government, how do you integrate the RE power? How do you have proper stability in the grid operation? How do you ensure a resilient grid operation so that the ease of energy access is available to everybody? That is our fundamental aim. That upgradation of the infrastructure, upgradation of the network, that is part and parcel of the system. Whenever there is a situation so calls for, things are being taken up. Suppose the transformer capacity is low, whether you replace the transformer with a higher grade or you put up a transformer in parallel, that economics needs to be carried out at the project level. It cannot be a policy level, state level decision. Suppose I need 20 MVA transformer right now and the capacity is 10 MVA. The requirement of the power has gone up. So whether I add another 10 MVA in parallel or shift this 10 MVA to another area, put up a 20 MVA transformer, this is a part of our infrastructure development exercise. So those things primarily depend on the project, the requirement, and the emergency and the need of emergency. So those things primarily decide how do you integrate the infrastructure improvement requirements.
In the present era, everyone is talking about modern systems, smart systems. But what I feel, before we go for any smart systems, you have to have system that can ensure the quality, reliability, resilience, redundancy, safety, sustainability, flexibility for integration of my systems, that is efficient and cost effective, then finally the smart. By having only a smart system is not going to serve the purpose. Apart from that, you have to ensure all others 9 characteristics I have mentioned. With all these things, if you make your system modern, smart, that is a real achievement for any power sector. This is my personal view on that.
Odisha was the first state in Pan India to have undertaken the power reforms. Way back in 1995, Odisha's discoms were privatized. The first state in India to do that. After that, also we have got power reforms in various phases. So today we have our power scenario is divided into different companies and entities with focused responsibilities and accountabilities. Generation companies like thermal generation called OPGC, Odisha Power Generation Corporation, they are only into thermal power production. That is generating unit. OHPC is Odisha Hydropower Generation Corporation. They are only into hydropower. Whatever they produce, OPTCL, Odisha Power Transmission Corporation Limited. They take care of the transmission part. Okay. And we have got 4 privatized discoms managed by Tatas. Tata Power Central Distribution Company Limited, Tata Power Northern Distribution, then Western Distribution, and Southern Distribution. So all the discoms are privatized and managed by Tata Group. And Gridco is the bulk power supplier to the entire state. We are the only licensee who will procure the power for the requirement of the state, supply to the discoms, and make payment to the suppliers. Our sources are not only the power generating companies of the state, but also we source power from outside whenever it is so required. And we are a power surplus state. Having said that, our requirement of power is around 7,000 megawatt, but we have an installed capacity of 20,000 megawatts. Thanks to all these thermal power projects which have come up in the last 1.5 decades, our installed capacity is much more than our actual requirement. So we are a power surplus state. Now, Odisha is having 2/3 of coal reserve of India's coal reserve, 2/3 of coal reserve in Odisha alone. So it is obvious that because of the large scale coal availability and low cost coal availability, the thermal power plants have mushroomed a lot. So now the challenge is how do you integrate the renewable energy, because already you are a power surplus state, and at the same time you have a mandate to reduce the pollution. And for your information, Odisha produces highest per capita carbon dioxide in pan-India, which is around 10% of national pollution level, which is already in an alarming state. We need to cut down by any means our emission level, come hook or by crook. The emission level has to come down. How do you do that? By integrating large-scale RE, renewable energy, and reducing our dependency on the fossil fuel. So Odisha is aiming to develop around 10 gigawatt of power, RE power, by 2030. Largely from floating solar, because Odisha is blessed with number of reservoirs. So herein floating solar would be developed, because we do not have much of land which is not used. These are all fertile agricultural lands. So large patch of lands for development of ground mounted solar is not feasible. So we are primarily focusing on floating solar projects. Then PSPs, we have identified around 50 gigawatt of potential is available. Wind around 2000 megawatt is available. PSPs, when the small hydro around 250 megawatt we are going to develop. Biomass and waste to energy, that is also parallelly going on, and green hydrogen and green ammonia production, 6.6 million metric tons per annum. That is what is being targeted.
Going to scale up more and more. There will be like, what will we do with the wastage? How we are going to, manage that wastage, whether it be battery energy storage, batteries, what you call the cells, the panels, and all. How we are going to, is it not going to affect the climate also when we are doing everything for climate, the things which we are coming at? So, Mr. Rajesh, what will you answer about this?
Yeah, I have mentioned in my slides that we talk about the one side of benefit, but there is second side of coin, that is the e-waste management and environmental and the health issues associated with the renewable energy integration. The first issues I have already mentioned is the land use. There is issues of wildlife, contamination of water. We must have proper waste management, the issues of emissions, noise, storage, climate. And the problem is that at present we don't have recycling facility, large recycling facility. We don't have norms. And the most important thing is that we have very weak regulations and extended protect response enforcement, EPR. We don't have proper decommissioning policies. There are some health and environmental issues are there that must be addressed simultaneously apart from the growth we are looking at. We have to make proper guidelines to address that issue, because if you talk about the life is of battery or your solar PV, end of life, how you are going to use recycle it, how to manage that dump of huge dump, not dump, the huge dump of these renewable panels and battery wastage. We must have a firm policy to address that issue in hand before that is too late.
I have a different connotation in this regard. There is a saying, popular saying, that creativity comes in adversity. Correct? So man can become more creative if he's pushed to the wall or there is an adverse situation. We are yet to reach the stage. 25 years is the predicted life of a solar panel. We are yet to reach that stage. At least the thinking has already started. The thinking process, R&D, has already started in this regard. That by the end of this lifespan, the design life is over. What do you do with this silicon-based solar panels? There are few companies who have come out with pilot projects already. We have a tie-up with IIT Bhubaneswar and STU Singapore. They are also working on those lines. Apart from many other lines, this is one of the lines where they are working on how do you dispose of them, how do you recycle them, reuse them. So those processes have already started dropping in. So by the time we will reach that phase of 25 years or 20 years down the line, we will have something in hand to dispose them of. Like these batteries, lithium-ion batteries. Predominantly today it is lithium-ion. Again, disposal is a question. Yes, I understand. They are more fire prone. They are more explosive prone. So those issues are there already. We know them. But still, then, unless it is adapted, tested, retested, you cannot have a solution to that. To have that, let us deploy them. And when the breeze comes, we will start of crossing over it. Instead of not doing anything, not adapting them in a large scale, if you think of disposal right at this moment, it is not going to be very productive. So my connotation would be, let us face the challenges, and eventually solutions will be there. It's not that no issues can be unsolved. There will be technologies available, there will be solutions available. And at this stage, our focus should be more on their adaptation part rather than their discarding part or disposal part. If you do that, then possibly we are not going to achieve anything.
Say,
I would like to add one more thing.
right.
Sir has talked about a useful life, that is 25 years, I do agree. But what about the premature failures, renewable panels? We still don't have any policy to recycle or manage the already failed panels in my systems. We have to work, we can't wait for 25, we have to address it immediately, we have to make some policies. There should be some mechanism to address the e-waste management as early as possible. We should not wait for that useful life 25 years to finish.
I'm working in BSCS Rajdhani. We are dealing with the distribution network for South and West Delhi. So we face a lot of challenges. See, the load is growing. Every year the load is growing. And we have to cater that peak load, which is for very shorter duration. But we have to cater, we have to augment and add our network in order to maintain and meet that peak load. And the influx of new consumers, which are being added every year. Every year on an average, we get 1.5 to 2 lakhs new consumers. So our network has to be ready for that. There are many challenges in that. Space is the biggest issue. We have limited space. We don't get space for new grids, new substations. So we have to adopt for higher capacity ratings. Like earlier, we were using 3-core 300 cables. Now we have shifted to 3-core 400, so that a single cable can take more load. Earlier, the transformer ratings which were being used in our network were 630 kVA, 400 kVA, 1 MVA to the max. Now we are going massively into 1.6 MVA because in a limited space, we have to cater the load. Similarly, for transmission, for conductors and all, we are exploring the possibility of HTLS and such type of conductors which can carry higher load. So those are the challenges we are facing, and we are adapting ourselves to bring out some solutions for that.
Okay, ma'am. Speaking about the challenges, there is one more thing which cannot be ignored or unnoticed. I believe there are skill gaps of workforce, proper management of the workforce development. What is your take on this?
Workforce development goes on as and when people work, right? You cannot expect someone to be learning each and everything. We are millennials, so we have to train the Gen Z for that. And in BSCS, we are working for that. Our whole HR team and the senior leadership is all aligned to bridging the skill gap with as many resources, as much trainings are required. On-field trainings, off-field trainings are required. They need to visit the sites, they need to visit the factories, the manufacturing units. All that is being done. But that is a gradual process.
I don't think there is a skill gap because the youth engineers are very smart. They know how to use that AI, ML, and technologies. The only thing, but I feel they have to get the proper training. They have to change their mindset. They have to make them ready to work in the field because they prefers to be on work on desktop or online. We have to cultivate the habits of going to the sites, show them the right way of doing things, how to ensure safety, how to do the actual things, and we have to adopt the latest technology for the asset management. We have to use the best practices of doing the work so that we can finish the job well in time. And as Deepti ma'am expressed very well, we have to uh, take care of the development of our systems. We have to do augmentation, additions based on the requirement, and we should be ready to do all these things. If we want to supply 24 into 7 uninterrupted supply the consumers we have.
See, we have several challenges. I told you with the space and network constraints. So in that case, battery comes into play where we cannot do anything. At least for peak shelving, battery can be used. So we are doing at lower levels also, at distribution transformers levels also. That helps in meeting the load as well as capex deferment. So that is the need of the hour. Now I have come to know there is plug and play batteries also coming for the distribution transformers and all. We are exploring that also. So maybe next year onwards, we'll be having that also in our network.